Section 4.3, we take a deep dive into quadratic functions and some of their properties. Quadratic functions are generally in one of two forms. Either the standard form, which is what you've seen a lot of through high school math and up through even this course, and vertex form, which is less common but is very useful at times. Now, what I want to be very emphatic on is that these two forms are merely different representations of the exact same mathematical relationship. And we will look at how that works out in this video. So what's nice about vertex form is that it tells you the vertex of the parabola. So when you look at HK, we've looked at this as transformations, but it's also where the vertex is. Because the vertex starts at the origin, this right here starts at the origin, the transformation, we can track where the vertex is going to be. So when you move however many steps up, down, left, and right, depending on how it shifts, that is where the vertex is going to be, hence the name vertex form. And so in vertex form, we can clearly identify where the vertex of this parabola is. But I want to be clear once again that vertex form is just a different presentation of standard form. So ax squared plus bx plus c. And to demonstrate that, we're going to take this parabola, which is currently in vertex form, and we're going to multiply it out and show that it really is the same thing as the standard form. So I'm going to multiply this out, x minus 3 squared plus 2. So x minus 3 squared literally means x minus 3 times x minus 3. I'm going to try to be consistent with writing this out neatly. But when I multiply this out, I got x times x is x squared, x times minus 3 is minus 3x, negative 3 times x is minus 3x, and negative 3 times negative 3 is positive 9. I'm going to once again bring down that plus 2. Now, when I start to combine like terms, what you'll notice is I have an x squared, I have minus 6x, those pieces right there, and then I have plus 9 and plus 2 is plus 11. So this is in that standard form, the general form, and it is perfectly mathematically equivalent to vertex form. Those are two representations of the exact same mathematical relationship, the exact same parabola. So there is no difference between them other than their presentation. Now, we can also go the opposite direction. So I started in vertex form and I ended up in standard form, but we can also go from standard form to vertex form. So if I have a function, let's say x squared minus 6x plus 5, I can actually put this into vertex form. And to do this, we're going to do a skill that we did back when we talked about circles, which is completing the square. Now, I know that this is a little bit different than we do with circles because we have f of x. But I do know that we are going to have to create a little bit of space, x squared minus 6x plus the perfect number. Now I'm going to just push this plus 5 over. Now one of the keys to doing this is compensating. So I know that the perfect number is going to be half of that middle term, b over 2 squared. So half of negative 6 is negative 3. And that's going to be, negative 3 squared, which is 9. So I have to add 9. Now before, if we added 9, I would add 9 to the other side of the equation. But the problem is, this is in function notation. So I can't just add 9 to the other side of the equation. But what I can do is compensate by subtracting 9. Because plus 9 and minus 9 is nothing. They perfectly cancel out. So I added a plus 9 and a minus 9. So I haven't actually changed this equation because technically all I added was 0, but it does now put this in a nice form to where I can look at this as a perfect square trinomial. That's going to be factorable, and that's going to be x minus 3 squared. And then I'm going to look at these pieces over here. 5 and negative 9 is minus 4. So minus 4. What that tells me is this is a parabola that has a vertex at the point 3, negative 4. That is where this particular parabola has its vertex. So once again, we can go from vertex form right here all the way down to standard form. And we can also start with standard form, complete the square, and end up in vertex form. So 2 different presentations, both very commonly used, and we will talk a little more about these in the next video.